Hello everyone, my name is Tyler Watson, and today I'll be sharing with you my Week 3 video lab report. The purpose of this lab was to examine the differences between the predicted time versus position and time versus velocity lab experiments compared to our observed time versus position and time versus velocity displayed during our lab time. Using our WebV Python, my group mates and I were able to conduct an experiment of a marker rolling across our lab table and measured at each distance it traveled each second. After recording our data, our group was able to conclude that our observed experiment was different than what our predicted data had showed in our Python code and graphs. This is most likely due to the air resistance and the friction of the lab table acting upon the marker as it rolled across the table. But we can use this data so that we can easily record and observe our experiments and then quickly apply them into our VPython coding and able to see that on our graphs here shown in a second. Some of the conditions we identified before we started the experiment was that our marker was the system and the surroundings included the table, the gravity, the air resistance, as well as the friction. And all of these forces acting upon the marker caused our observed data to be different than our predicted. So I quickly wanted to go through our code that we created here. So as you can see, this was copied from our template used in Canvas. And I changed some of the data to apply to our experiment. So as you can see, our measurements were in centimeters per second as well as centimeters. And as you scroll down for the velocity versus time graph, I started the position at 12 and worked our way down because we started our initial push of the marker at 12 centimeters per second, and it decreased at a rate of 2 meters per second over time in our observed graph. So as you can see, we measured our data between 0 and 8 seconds. This shows our data that we have created into coding format. And so above here is our predicted, up here is our predicted graphs, and down here is our observed over time. So as you can see, it decreases at a rate of 2 centimeters per second. And this is what we were able to come up with when we run the program. So as you can see in our predicted position versus time, it is slowly moving away from 0 at a constant rate of speed. And basically what we were able to conclude was that at 8 seconds, the marker should have been 96 centimeters away from where we started. This shows a constant speed over the entirety of the 8 seconds. But when we actually did the experiment ourselves, and what we were able to observe was that the marker slowly slows down as time continues because of this friction and air resistance on the marker. So we started off at a rate of 12 centimeters per second and slowly decreased at a rate of 2 meters per second. So as you can see over time, our marker is slower and slower, coming down to a complete stop. Obviously, the marker is not going to come backwards, but for the sake of this, at 6 seconds, our marker has reached its fullest potential away from our starting position at 35 centimeters. And scrolling down, you can see that the constant rate of change of our velocity is -2 meters per second. And down here is all of the data of our predicted data that we're expecting to see when we did this. But this is what we were able to observe from our experiment. Some of the errors that we experienced in this experiment was the force of the push on the marker. We knew it wasn't going to be perfect, as well as the weight of the marker was not totally equally distributed. I think if the marker was a perfect cylinder and we were able to create a machine that was able to push the marker at a specified force, I feel that our data would have been a little more accurate and we would have been able to come to more conclusions from this data. But our main conclusion of this experiment was that the air resistance and friction and other forces acting upon the marker, as well as those small variables, were able to show that the marker slows down over time, representing Newton's second law. And this was shown in our graphs as well as our code. But this is what we were able to come up with. Appreciate you listening to me. Let me know if you have any questions. Thanks.